In this lecture, we will graph the cycloid defined by the given equations for t on 0 to 4 pi. This equation is the equation of cycloid. It's a parametric equation. Here we want to understand what's the meaning for t. Okay, let's look at this picture in order to understand the equation of this one. You know, this is a circle or the wheel. Okay, previously this was the center, it was here. Okay, and then this wheel rotates on the ground or on the x-axis. When the center was on 0, 5, the tangent point, this point, was on the origin. Okay, and then when the center moves, this tangent point was here, it moves to the right and also move up. Okay, now we know we want to figure out the coordinate of this center. We then should be able to figure out the coordinate of this tangent point, which was originally from here. The y-coordinate is pretty easy to figure out for this center because, you know, from the center to the ground, it's always the radius 5. So 5 is easy to figure out. But why this x-coordinate is 5t? Why this part is 5t? You know, this is the part on the circle. This arc has touched the ground. When the wheel rolls on the ground, the center goes from here to here, and then this arc will touch the ground up to this far. This is the new tangent point. Okay. How long is this arc? Of course, this part has touched the ground, then this length equals this length. How long is this length? How long is this arc? The length of the arc equals the radius times the amount of central angle, t, right here. Okay, so 5, the radius, times the amount of central angle, which is t, so 5 times t is the length of the arc, and this part has touched the ground, so equals this part, and that will be the x-coordinate. So that's 5t. Okay, so x-coordinate is 5t, and y-coordinate is just 5. So this is the coordinate of center, 5t, 5, 5t, 5. Okay, 5t, 5. This is the coordinate of the center. But we cannot stop right there. We want to figure out the x-coordinate, this part, and the y-coordinate, this part. Yeah, we want to figure out the coordinate of this one. Then we go to look at this red triangle. Okay, the red triangle, the opposite side over hypotenuse is sine t. Then, of course, the opposite side equals the hypotenuse 5 times sine t. So opposite side equals 5 sine t, and then the longer one is 5t. So 5t minus 5 sine t is the x-coordinate. So 5t minus 5 sine t is the x-coordinate. Okay, so we got x of t is this expression. Now, similarly, this short leg is cosine t times 5, or 5 times cosine t is the adjacent leg. The adjacent leg is 5 cosine t right here. And then we know the longer one, that's the radius minus 5 cosine t, the short one, will be the distance from tangent point to here, which is y of t. Okay? Yeah. So that's the meaning for this parametric equation. T stands for the amount of central angle. Now we got to figure out for the different t, what are the values of y? Okay. Now, we will do the algebraic thing first. Okay, and then I will explain the actual meaning. Starts with t equals 0. Then when t is 0, 0, 5, 0 is 0. Minus 5 times sine 0. Sine 0 is 0. So, x equals 0 when t is 0. Similarly, when t is 0, cosine 0 is 1. And then 5 times 1 is 5. 5 minus 5 is 0. So when t is 0, everywhere x and y are zeros. Now, when t is pi over 2, then you will have a 5 pi over 2 minus 5 sine pi over 2 for x. For y is 5 without t minus 5 pi over 2. Minus 5 times cosine pi over 2 is right here. Okay? So, downstairs is easy to figure out because cosine pi over 2 is 0. Times 5 is 0. 5 minus 0 is 5. Upstairs, when t is pi over 2, sine pi over 2 is 1 times 5, so is 5 minus 5. And t is pi over 2, and then is 5 pi over 2 minus 5 is approximately 2.9. So when x is 2.9, y is 5. Is the point right here. This is 1 unit, 2 unit, about 3 units is 2.9. Okay, when x is 2.9, y is 5. Okay, so this is the point. Now, then you got to figure out when x is pi, you plug in, t is pi, you put in right here. Okay, you have a sine pi is 0, and times 5 is 0, and 5 pi is for t. Okay, and then cosine pi is negative 1, times negative 5 is positive 5, add 5, you have a 10. Okay, so then we have a 5 pi 10. So 5 pi is roughly here. Okay, you use 3.14 times 5. Okay, is like above 15. So 5 pi is right here, and y is 10. 10 is this high. Okay, now it keeps going. So here I choose the typical point, pi over 2 pi, and then 3 pi over 2 for t. Okay, at 3 places. Then you know you will calculate. You plug in 3 pi over 2 here and here to calculate. And then you also plug in 3 pi over 2 right here, you calculate. Here are the algebraic thing. You will have x is 28.6 and y is 5. Okay? So, where is 28.6 and 5? 28 is roughly here, 0.6 is close to 29, and y is 5, so it's right here. Okay? So you have a 1, 2, 3 points plus origin. When x equals, you see the next point will be 2 pi. You figure out yourself. Then you will have x will be 10 pi, and y you will get 0. So basically the curve looks like that. Okay, that's cycloid. And then there's t completes one period, because here the period is what? Is 2 pi. Okay, sine has period 2 pi, so it's cosine. Okay, so when t completes one period, it goes like that, and another one goes like that. So here requires from 0 to 4 pi because of the space. I did from 0 to 2 pi, and then you may do more. Okay? Now, this is the algebraic way. We figured out that when t is pi, you have 5 pi, 10 pi, and 5 pi, 10, and 10 is the highest place. Now, that's a good thing we got is that right here is the highest point is y is 10 when x is 5 pi. And then you know you will have a 10 pi, that's when t equals 2 pi. You will have x is 10 pi and the y is 0. But also, you know, this is the algebraic way we find, and we can even think about this, about the movement when this wheel is rolled on the ground. You know, previously the tangent point was on origin. When is the next time it will touch the ground again? We know it will touch the ground somewhere here, and we know algebraically is 10 pi. Why is that? You put 2 pi here, you'll get x is 10 pi, y is 0. You calculate. I didn't put the details right here, but you can do that. But y here is 10 pi, we can think about in another different way. You know, previously no point has touched the ground, and it was only this tangent point on the ground. The second time it touches the ground, it must, every point on the circle has touched the ground, then this point will touch the ground again. This point, it was here. The next time it touches the ground is every point on the circle will touch the ground. Then is the length of the arc of this circle. How long is this circle? How long is the circumference? Is the circumference? You know, the length of the circumference is pi times the diameter. Pi times the diameter is pi times 2 times 5, because the radius is 5. Okay? Radius is 5 times 2 is the diameter, and then times pi is the whole circumference. So that's how here is 10 pi. Okay? Yeah, it previously touches from origin. The second time this point under a wheel touches the ground will be 10 pi, which is the circumference. So this 10 pi can be got from two different views. One is through the parametric way, another is calculated through the movement. Okay? Please review this lecture. I'll see you next time.